Hey everybody, Mr. Withers here, back for another week of circles work. Today we're going to talk about two sections in the book, 10.5 and 10.6. Your assignment's only going to happen kind of on one section, and I'll show you that at the end here. But I think you're going to enjoy this. It expands on last week's lesson and actually is relatively simple, I think, compared to what we've been working on recently. So this section focuses on what we call secants and tangents. And the first thing we need to make sure we clarify, this is not tangents like trigonometry tangent, where we do opposite over adjacent, dealing with triangles, and that's SOHCAHTOA. This is a different word, tangent, dealing with circles. Just make sure we don't get those confused. And we're going to start out with that definition of tangent right away. And a tangent is simply when a line is just touching a circle. So when a line's just touching a circle, it is a tangent. So if I had circle O here, this would be an example of what a tangent would look like, a tangent line. So we have a theorem for tangents, and that says that the radius drawn to that tangent point is perpendicular to that tangent. So if I draw a line from my center to the point where my tangent line intersects with the circle, those lines will be perpendicular. So that's something good to keep in mind, as you might see sometimes a radius drawn intersecting with a tangent, and it won't tell you that that's 90 degrees. Knowing this theorem can prove to us that yes, that always is 90 degrees, so we can know that and use it when we're trying to find missing pieces. Let's define the word secant. A secant is a line that goes through a circle. And I know it really bothers some of you that through is spelled that way, which is why I leave it, because, I don't know, just like getting under your skin a little bit. So a line that goes through a circle. So, for example, this would be a secant line, intersects the circle in two places, goes through it. This would be another example of a secant. This would be another example of a secant. You get the idea. A diameter of a circle would be another example of a secant, as it is a line that goes through the circle, intersecting it twice. And secant angles are what we then create. And this is really where we're headed with today's lesson. This is the new content that we're going to be talking about and the types of problems you'll be solving. When we have two secants going through a circle, angles are formed. And those angles happen in one of two places. They can happen inside the circle. So in this case, both secant lines intersect inside the circle, and so our secant angles are formed inside the circle. We could also have secant lines intersect outside the circle. So in this case, you can see that our secant angle happens outside of our circle. So two different areas that this could happen, could take place. And we've got different rules based on where that angle falls, whether it's in the circle or outside the circle. So we're going to get into a couple examples of that, and that'll be essentially the gist of your assignment today, is practicing these calculations with secant angles. So let's take a look. So our first secant angle theorem. If that secant angle falls inside the circle, like we saw on our previous slide, something like this, then the measure of angle x, or that secant angle, will be 1/2 of the sum of our two arcs. So if I take arc A and arc B, so we have to think back to last week about how these arcs all have angle measurements, right? If I take arc A and I take arc B, I add them together and divide by 2, that will equal the measure of angle X. Now, if we were meeting in person, I would take you through a proof of why this works to kind of give you the rationale or the reasoning behind it. Just for the sake of time and because it's tough to explain without being in the room with you, I'd like you to just trust me on this one, that this theorem is correct. If you're really curious, you can Google this. You can check it out on YouTube, on Khan Academy. There is mathematical proof for this theorem, but for the sake of time, we're going to just trust it today. So let's try an example. Let's say that we have two arc lengths of 130 degrees and 84 degrees. If I want to find angle x, which is there in the middle, all I would need to do to find the measure of angle x is 1/2 the sum of my two arcs. So if I take my calculator, I add 130 plus 84, and I divide by 2, you find that the measure of angle x is approximately 107 degrees. Now, obviously, this is not to scale. We know that 107 is an obtuse angle and angle x is an acute angle, but you get the idea. Okay, we would simply add the arcs and divide by 2 to find that angle measurement. Now, you might be thinking to yourself, well, Mr. Withers, what about angle y? How do I know which one I'm doing? Well, the same rule applies that we've had when we work with lines our entire mathematic career. Okay, these are vertical angles, so they're going to be equal to each other. So either way, you're going to add the arc lengths and divide by 2. Angle x and angle y would both equal 107 degrees. Now, we're not always going to be given those arc lengths. Let's say, for example, you had a similar problem, but this time you're given the central angle, again, not drawn to scale, I realize that, the central angle of 110, and we're given one arc, and the other arc we're being asked to find. Oh, we can use this just like an equation. So if we know that measure in the middle is 110, and we know that that should be 1/2 the sum of my arcs, this is just a very simple equation for us to solve. Okay, so if I take both sides times 2, I end up with 220 equal to x plus 97. If I take 220 and I subtract 97, we find that the measure of x, or arc, is 123 degrees. So you can see how using this theorem, regardless of what information we're given, we can find those missing parts. All right, let's move on to our next portion here. What happens if the angle's on the outside? So remember, we talked about how sometimes when those secant lines intersect, they're going to intersect outside of the circle. Okay, so if it's inside, we add the arc lengths and we divide by 2. If it's outside, to find that measure of angle x, we take half of the difference of the arc lengths. So instead of adding them together and dividing by 2, we're going to subtract them and divide by 2. Now, it would make sense to take the larger arc minus the smaller arc, okay? Because if we do it the other way around, you're still going to get the same angle measure. It'll just be negative, and we don't generally talk about angles in negative terms. So just for the sake of simplicity, I would take my larger arc, I would subtract my smaller arc, and I would divide by 2. So if we want to try a quick example of that, let's say that these angles intersect outside of our circle, and we're given the two arcs measurements of 207 degrees and 95 degrees. So just like we'd done before, the measure of angle x is going to be equal to 1/2. This time we are taking the difference of the arcs because that intersection happens outside the circle. So if I take 207 and I subtract 95, I get 112. And if I divide that by 2, I end up with a measure of angle x equal to 56 degrees. So we would have that angle outside of our circle. We could find the measure of that angle just simply based on the arc measurements. Let's try another one. This time, I've got a different situation. This time, I've got two variables. Okay, this is not as difficult as it might look. Both of my lines are tangents. They only intersect my circle in one place, here and here. So if I know that this arc is 102 degrees, I would hope that we could kind of rationalize our way through this, that this arc, or arc Y, would have to be what? Well, if we know the whole circle is 360 degrees, if I take 360 and I subtract that 102, that is part of the minor arc, I end up with 258 degrees. Oh man, that 8 is terrible, sorry. 258 degrees. That makes up the rest of that circle. Now, we kind of lucked out here that both of these lines were tangent lines so that we could take the circle as a whole to find that missing piece. However, in this situation, yeah, absolutely, we could just take 360, find that missing piece. Now, the measure of angle x shouldn't be a problem at all. To find the measure of angle x, all we need is 1/2. Remember, this falls outside the circle, so the difference between our two angles, so 258 minus 102 equals 156. And when I divide that in half, I find that the measure of angle x equals 78 degrees. So I'm hoping that this feels relatively simple for you. This is one of those lessons that I think is kind of fun because all it's going to ask you to do in your assignment today is look at a bunch of circles with a bunch of secant and tangent lines and kind of just figure out the puzzles. So I've always really enjoyed this section. All right, before I give your assignment to you and let you go today, I do have one special case. What happens if the angle is on the circle? So we talked a lot about what happens if the angle falls inside the circle, what happens if the angle falls outside of the circle, but we do have one special case, and this could happen where the angle falls directly on the circle. Okay, so that would be something like this. So we can see that these are both secant lines. They're not tangents because they intersect our circle twice, but they share one of those intersection points, and our angle falls on the edge of the circle. Well, lucky for us, this is the easiest of the three formulas. If our angle falls on the circle, we just take half of the arc, which I think, if you really kind of break it down and look at it, it makes sense, right? We only have one arc to deal with, so finding the difference or the sum of the arcs doesn't make any sense because we only have one, so we're just going to take half of it. Okay, this should look familiar from a theorem that you saw last week, where we talked about if the angle originates from the center or if it originates from a side of an angle, or sorry, a side of the circle. And if it originates from the side of the circle, we talked about you just take the arc and you divide by 2, or if you have the angle, you multiply by 2 and it gives you the arc measurement. So this is exactly what we talked about last week, but now we can see this falls right into secants and tangents that we've been working with as well. So you'll just take your arc length and you'll divide by 2. So let's say, for example, I know that this arc is 160 degrees. If I want to find the measure of angle 1, it would simply be 80 degrees. Okay, that one actually might be to scale. We're pretty close there. Okay, so very simple. If the angle falls on the line, you might see one or two of those in the assignment today, but for the most part, we'll be using those other two formulas. All right, so hopefully that makes some sense today. Your assignment, and I'm actually going to give you some specific problems today. Essentially, you're going to be working through the first 2 pages of this section in the textbook. So I'll post page 745, and I think it extends into 746 on the website for you. You're just going to do 1 through 23 all. Just take a look at that whole set of problems. Some of them are kind of puzzly. Some of them are very straightforward. All you're going to be doing is finding angle measures and arc measures. My answer key will be posted there as well for both 745 and 746. So you can check your work along the way. If you have some mistakes that you're not sure why you made them, or you're not sure how the answer key ended up getting the answer it did, just drop me an email. I will make a short video, or I'll write the workout step by step and I'll send it back to you real fast to kind of help you get through the assignment. So nice short video this week, I think only about 15 minutes. Hopefully this makes some sense and you get some good practice. This week's retake is over quadratics. So you'll need to solve those one set by completing the square, one set by factoring, and one set by the quadratic formula. So I think there's 6 problems total. If you decide to retake that, or if you want to only do a section of that, if you just have one of the scores you want to improve, that's fine as well. Send me whatever you decide to do or retake. I'll grade it. I'll update PowerSchool. Real smooth and very quick. So drop me an email if you have questions. Have a wonderful week. Stay safe, stay healthy, and we'll talk to you next week. Bye-bye.